Hi students, today we are going to learn about evaporation. Evaporation is quite a common phenomenon. We see it all around us, don't we? If we keep water outside for some time, the water evaporates. There's no doubt about it. Even the earthen pots that some people use in their houses work on the principle of evaporation. What exactly is this evaporation? How does it take place? And what are the factors that increase evaporation and decrease evaporation? We are going to learn about all these concepts in this chapter. Let's proceed. First of all, let's understand what is evaporation in the first place. The process of a liquid changing into a gas below its boiling point is called evaporation. You see, in our last chapter, we had studied, that when we heat a liquid to a certain temperature called its boiling point, in that case, the liquid changes its state and becomes a gas, isn't it? We had studied that. However, even when we don't heat a liquid to its boiling point, many times the liquid changes into a gas. This changing of a liquid into a gas below the boiling point is called evaporation. As you can see, in rivers and lakes, water evaporates all the time. The level of rivers and lakes, decreases during the summer months when there are no rains, because no water is being added to the rivers and water is getting evaporated all the time. That's why, the level decreases. Similarly, if you keep, a bowl of water on a table for some time, then as time passes, the water from the bowl evaporates. It all turns into gas. So the evaporation is quite common in our daily life, and it occurs definitely much below boiling point. After all, rivers and lakes are at room temperature, and this bowl which is placed on this brown table here is also at room temperature. Now, what causes evaporation? Like when we studied boiling in the last chapter, we had studied that, when we increase the temperature of a liquid, then the kinetic energy of the particles of the liquid increases, the particles start vibrating faster and faster, and at the boiling point they escape and form a gas. But in case of evaporation, we are not even increasing the kinetic energy. So how is evaporation taking place? Let's understand exactly why evaporation occurs. You see, this is a liquid. The green particles you see here are the particles of a liquid. Now, in a liquid, one interesting point is that the particles at the surface have a greater kinetic energy than the particles in the bulk. This means that, if you have a glass of water, then the particles at the top of the glass of water, that is the particles of the liquid which are exposed to the atmosphere, they have a much greater kinetic energy than the particles deep inside the liquid. This is because for the particles deep inside the liquid, the forces of attraction, the binding forces from all the other particles are in all directions, isn't it? So if you consider this particle here, which is deep inside the liquid, this one, in that case it has forces of attraction from all sides, isn't it? The particle here is attracting it, the particle here is attracting it, the particle here is attracting it. So the freedom of movement is quite less, isn't it? Because particles from all sides are attracting it. However, if you look at the particle on the surface, the particle on the surface does not experience any force upwards, isn't it? It experiences a force from this particle here, downwards, but there is no upward force, isn't it? No upward force, because the surface is free, and therefore you can say that the particles at the surface have relatively more freedom compared to the particles inside the liquid, the particles in the bulk. And that is the reason the particles at the surface have greater kinetic energy than the particles deep inside the liquid, because the particles at the surface are not restricted at least in one direction, isn't it? Their motion is not restricted in the upward direction. It can be restricted in other directions, but at least they are more free and they have more kinetic energy therefore. And therefore, it is easy for the surface particles to escape from the liquid as they have less attractive forces to overcome. And that is the reason that even at room temperature, randomly some particles from the surface escape from the liquid, like this. So, even though the rate of escape of the particles is not as fast as in boiling, even then, particles do keep escaping after some time. You can see a particle escape here. See, two other particles have escaped here from the surface. So particles from the surface, since they have more kinetic energy than the other particles in the liquid, they keep on escaping randomly, after some time. The probability of the particles at the surface, having enough kinetic energy to escape from the liquid is very high. And that is how the liquid evaporates, slowly but steadily. So that was the explanation of exactly how a liquid evaporates. Understood? This might seem a bit complicated at first, but if you carefully visualize, how the particles at the surface are moving faster and how some of them just randomly escape after some time, you'll understand evaporation.